Hello students, welcome back to my channel. In today's session, we will be learning another sorting algorithm, and this time it is going to be Quicksort. So this is going to be the last sorting algorithm which we will be learning in this particular series. And this is the 27th algorithm what we are learning in this particular playlist. So let us go ahead and see. Like we all know what is sorting. Sorting is nothing but we have a n number of given elements and our final agenda is to sort it in a ascending or a descending order. So what is this quick sort? So given a randomly ordered set of n integer, sort them into a non-descending order using a partitioning method. So here whenever we are talking about the quick sort, here we will use the partitioning method where we have a given array and we are going to take a pivot value or a pivot value. This value we are going to consider to be as a value from through which we are going to sort the given array. Okay, so we will see that in detail. So before that, let us go ahead and see the other details about this particular array this particular algorithm. Okay, so what is the core concept of quicksort? So main concept is first thing is choosing a pivot element. So select an element from an array to act as a pivot or pivot element. So once we have that element, we have a element in focus. What we are going to do is we are going to reorder the elements. So rearrange the elements such that all the elements less than the pivot becomes before it and all the elements greater than the pivot comes after it. So if this particular 25 is my element, I'm going to rearrange initially the remaining element in a way that the all the values less than this pivot element is going to come onto the left side and all which is greater comes on the right hand side. So this way what we are going to do is once we have our pivot element in its position, then I'm going to only focus on the remaining array. So this in this way I'm going to partition my array. Next, in this array itself, I'm going to choose another pivot element and then I'm going to arrange the element as less than and greater. And once again, I'm going to only focus on these two arrays. So in that way, I'm going to continue doing this unless I reach a single element. And by the time I reach a single element, my array would have sorted. So that is what is a partitioning process is. So once we have reordered the elements according to the pivot element, but that is the values less than that and greater than that, the pivot element is placed in its final sorted position. So that is what I said. Once we have this arrangement, we assume that this has reached its correct position. Now we are only focusing on the remaining element. So, and then we will use the divide and conquer. That is recursively apply the partitioning process and on the sub arrays on the either side of the pivot. So that is what we are going to do. So when we take an example, it's going to be clear. So basically, you need to understand that the first step is we will choose a pivot element, then reorder the remaining elements. And then when we reorder, we assume that the pivot element has reached the correct position. And now our focus shifts to the other elements, which and because of this pivot element, we have divided the given array. All right. So what is this strategy is what we need to do. So as we know that the selection of this pivot element becomes very crucial. So based on that itself, we will be deciding because whenever I'm taking an array, if you see many algorithms, they choose sometimes first element as a pivot element, middle element as a pivot element, or sometimes they will choose the last element as a pivot element. So that is left to you, or that is left to the algorithm, whichever is the fastest. But there is no perfect way to do that. There is no perfect way to choose a pivot element. So you can follow any one of them. So that is the reason first element, simple but can lead to worst case performances on the already sorted data. So if you're taking a first element and suppose you have an already sorted this data, this can end up in a worst case situation. Okay, but if you're choosing a last element, similar to the first element, easy to implement, but not always optimum. Even the last element is not always optimum. Random element reduces the chance of worst case behavior, offering a good average performance. And median of 3. Fix the median of the first, middle, and the last element, improving the performance on various data sets. So each and every element, choosing whichever element as a pivot element has its own merits and demerits. That's the reason I have given you this one outlook on what could happen if you're choosing any one of these elements. The algorithm what we I have discussed here is here we will be choosing the first element as a pivot element and we will see how it is going to perform. All right, so that is the reason when it comes to the quicksort, choosing a pivot element or a selection of a pivot position becomes a very crucial. Okay, so before we get on to the algorithm itself directly, let us briefly see now that we know roughly how does a quicksort work. Let us briefly discuss with an example. All right, so now here what we are going to do is we have two algorithms which we are going to use. One is called as quicksort, okay, where I'm going to take an algorithm, a low value and a high value. Now what is this low value and high value? This is nothing but suppose I'm taking an array. Let me take the values 45, 36, 15, 92. Let me take 92, bigger value, 35 and 71. Suppose these are my element. Then what I'm going to do is this is the index 0, 1, 2, 3, 4, and 5. 0 becomes low and 5 becomes high. Okay. So whenever I'm talking about the quicksort, now we already know that I am going to take a pivot element here. Now, what is going to happen is after the quicksort, I'm going to call a partition function here. So what is this partition function? This partition function will also take the values, the same entire array it is going to take. Now, once it takes it, what it is going to do is within the partition, we are going to partition this particular array. Suppose I'm taking first element as a pivot element. So let me say that 45 is my pivot element. So according to this, if I have to arrange it, 15, then we have 35, 36, 42, 71, and 92. So according to this, 45 is supposed to be coming at the third position, isn't it? So now 45 is going to be here after the completion of the partition. So we'll see how that works, okay? And then this will be divided into two parts. All right. So my 45 is going to come here and remaining element will be sorted in this way. Now, this is nothing but a partition. So now I'm not going to touch this. Now I know that the initial pivot element, whichever I took, is in the correct position. Now I am only focusing over here. So once again, I'm going to call a quicksort algorithm for array and whatever the indexes here are. And similarly, here I'm going to call the quicksort algorithm for the array and whatever the remaining indexes are accordingly. And this will further call the partition function. And again, the elements will be partitioned. Obviously, because there are three elements, I'm assuming that this is going to be our final element. And of course, when we reach the single element, we assume that it is sorted. Similarly, after this, what is going to happen is our element will be divided in this way. One will be a partition element, one will be the pivot value, one will be the element which need to be further called as a quicksort. But since it is a single element, we are not going to call further again. Alright, so this is what is the concept of this particular algorithm. So let us go ahead and see the algorithm and we'll quickly trace it with the help of that. Okay, so as you can see here, so what we are going to do is initially, if low is equal to less than high, that is, if at all I'm having an array, I am always making sure that my low value should always be less than high value. Only then I'm going to call the partition function. Now, once I'm calling this partition function, what it is going to return is it is going to return the position of the pivot value. Okay, so it is going to return the position of the pivot value. So initially, if the pivot value, for example, suppose that 45 was the pivot value, okay, then I said that further my array need to be divided in this way. Totally, I had 6 elements. Now that I know it is in the correct position, as you can see, I'm going to call the quicksort function between a comma low. Okay, low is nothing but obviously because this is being taken from here. There are 6 elements. Of course, this is the first array. This is the pivot value, and this is the second part which is in focus. So it will start from 0 obviously, and it will go up till now j. I know that j is the correct position, so I'm going to go up till only j minus 1. Okay, which means I need to go only here. Now, next quick sort is going to be from, of course, I'm going to ignore this part because it is already sorted. This is nothing but j plus 1. That is why array, comma, j plus 1 going to be the low value. And of course, I'm going to go up till high. I hope this is clear. So further, I'm going to go on calling in this way. Okay, so this will happen in a recursive way. So this is your quick sort. Okay, now let us go ahead and see how does this partition work. The quick sort is very simple. I'm going to check if low value is less than high, and if it is so, then I'm going to call a partition function, and after that it will going to return a j value. J value is nothing but the position of the pivot element, and once I get that, I'm going to call the two more quick sort function. Obviously, when I call this quick sort function, I hope all of you know what is a recursion. This is further going to call another partitioning program, partition function, and it will call a quick sort. Okay, and then one more quick sort is going to be called. Similarly, this quick sort will also going to call a partition function, quicksort function, and another quicksort function. So this is go on going to happen. So every quicksort is going to further call three more quicksort functions. This will go on up till we reach the single element. All right. Okay. Now let us see the partition function. Now this might look a bit complicated, but it's very simple. Okay, so here what is going to happen is I'm going to take pivot value as low. I now remember, suppose, let me take the same example. I hope all of you are taking it down. So 45, 36, 15, 92, it was 35 and 71. If I'm taking this, and I had called the quicksort function of low and high. So this is 5. So quicksort function of a comma 0 comma 5 was the call. So which means this was a comma 0, sorry, partition, not quicksort, partition function of this one, 0 comma high. So now I know that my pivot element is going to be, pivot or pivot element is going to be the low value. Low is nothing but 45. 45 is going to be or 45, I can rather say that 0. 0, 45 is where 0, zeroth position, which is nothing but 45. Okay, and I is equals to low. So I is also is going to be 0 and j is equals to going to be high. Now, very first condition is I should be always less than j, which is of course true, which is 0 is less than 5. Now, once that is condition condition is true, we have two more while loops to check here. So basically what we are going to check is we are going to take two indicators here, I and j. And I is going to check if these values are less than the pivot values. That is, I'm going to, if the value is less than or equal to, then I'm going to retain it. The moment I find an element which is greater than the pivot value, I'm going to stop my proceeding. Similarly, J is going to check if the values are greater than the pivot value. The moment it finds that there is a value which is less than pivot value lying on the right hand side, we are going to stop. Now, what is this reason? Reason behind, like I told you before, I'm going to find the position of the pivot value. So that is what we are doing. So initially now I'm taking 45 as a pivot value. Now I want all the elements which are less than 45 to be on the left hand side of 45 and which are greater has to be on the right hand side. So whenever j finds something which is lesser than here, we are going to swap it with I. Similarly, whenever I find something which is greater than the 45, it will stop and we are going to swap the position. So this particular for loop is to find out the values which should be less than, but it is lying on the right hand, but it is greater than and lying on the left hand side. And this particular for loop is to find out the value which is less than pivot value, but it is lying on the right hand side. The moment we find that, we'll stop the loop and we are going to swap it. Okay. So, and we will repeat it until all the condition becomes false, and then we will return the value of the j. So when we are going to return the value of j is when we have the pivot value has reached the correct position. All right. Now we will quickly do the example. We will iterate it in C, then it will be clear. Okay, so let us come here, and I hope you all have taken the screenshot of the algorithm, because we will now follow the algorithm and we will do it. All right. So the given array is, please write down, 45. I'm going to take the same example, simple example. You can take the negative values also. Okay, not a problem. It will work with that as well. All right. Now let us start the algorithm. Now, the initially, the we are going to check. This is the quicksort algorithm. I'm going to check if I is less than j. Okay, of course, I value is 0 and j value is 5. It is less than j, and I'm going to call the partition function. So j is equal to, sorry, here it is not, I is less than j. It should be low is less than high. Always low value should be less than high. So initially this is low, this is high. All right. Now it is going to call a function partition of a comma low comma high. Okay. So let us see the partition function. In partition function, initially I'm going to take pivot value is equals to I. Okay, which is nothing but I or low, I can say, which is nothing but 0. I is also going to be equal to 0, and j is going to be the high value. Okay, so this is what is the condition. The very first time what we are going to do is, now this is the partition function I'm tracking, remember. We are more focusing on the partition function, so that we will, once we get the value, we will go back to the quicksort. All right. So now what is going to happen here is, I'm going to check the very first while loop checks that whether I is less than j. Of course, it is true in this case because I value is 0 and j value is 5. Now what I'm going to do is, I'm going to check the value while the second inner loop, where it is going to check the value of I should be less than high. Okay, of course, 0 is less than 5. This is true. And another condition, it says that the value of 0, that is a of 0, which is nothing but 45, should be less than or equal to the value of pivot. The pivot value is here 45. Since this is also satisfying, because equal to condition is satisfying, when both the conditions are true, what we are going to do is, we are going to increment the I value to 1. Okay, which means now I value is going to become 1. It's a simple concept. So we are going to keep the I value here. We are going to go on incrementing it. Suppose, as in, provided two condition is satisfied. One is the values are less than or equal to the pivot value, and also that we are not crossing the high value. And one more thing is, yeah, those are the two conditions. I value should not cross the high value. High value. I should not cross high value. Also, the value of the pivot should be greater than the remaining values. The moment we find the value which is greater, we are going to stop the increment of I. Okay. So now for I is equals to 1, let us check. So I is equal to 1, it is nothing but when I is 1, I is going to be here. 36 is still less than or equal to 45. Still it is true, which means I can increment the I value to 2. Now let us check 15. So 15 is still less than or equal to 45. It is true. Let us increment the value to 3. When I come to 3, as you can see, it is not less than or equal to 45. This becomes false. Now we found a value which is greater than the pivot value, which means I'm going to stop here. The while loop becomes false, which means we will move on to the next while loop, which checks whether pivot value, which is 45, it should be less than the a of j value. Now, where is my j? J is over here. Now, 71. Is 71 greater than 45? Yes, it is true, which means I can decrement the value of j. By decrement, I mean I'm going to move j inwards. Next value I'm getting is 35. Yes, 35, is it less than 71? This is false. This is not true. Hence, I'm going to stop the while loop. Now, when both the while loop becomes false, next thing we are going to check is whether I is still less than j. Of course, in our case, I value is 3 and j value is 4, which means now we have to swap the value of I and j. Okay, so that is what is going to happen. We are going to swap, and the new value of the array is going to be 45, 36, 15, 35, 92, and 71. I hope you're getting. Any doubts, please comment in the comment section. I'm going to give you a clarification. Okay, so now this is my first swap which I did. Now remember, after swapping, we always have that outer loop, okay, while loop. My first while loop became false, my second while loop became false, but the outer for loop is still there. Now, once again, I'm going to check whether I is less than j. Yes, my I is still less than j. Okay, though we have swapped, I is less than j. So once again, I'm going to get in and I'm going to check while I is less than high. Yes, I value is less than high. It is true. Okay. Also, now I'm going to check. Now remember in 1, 2, 3, 4, and 5. Now I'm going to check whether 35 is less than or equal to 45. This is also true, hence I'm going to increment the I value to 4. Now I value is over here. Now I'm going to check whether 92 is less than or equal to 45. Now this is false. I'm going to stop the while loop. Go to the next while loop, second while loop, where I'm going to check the value of j. Now I'm checking if the value of j. Now remember j is here. I'm going to check whether 92 is greater than the pivot value, which is 45. Yes, it is greater, which is true, and hence I'm going to increment the that's as an decrement the value. So I'm going to come to 35 and I'm going to check if it is greater than 45, and it is not true, it is false, hence I'm going to stop, which means my j is over here. J is at 3 and my I is at 4. Remember, now our new I value is 4 and our j value is 3. Now, once this particular algorithm, the while loop fails, I'm going to come out and I'm going to check if I is less than j. Then I'm going to swap a of I with a of j. But in this case, it is false. Hence, I will come out of the that particular condition and I will directly go to the outer loop and I will check if I is less than j. Here also this become false, hence I will come out of the while loop entirely. Now what I'm going to do is I'm going to swap the pivot value with a of j value. Okay, so now if you can go back to the algorithm and check. Now we are going to swap. Once all the condition fails, we are going to swap the a of j with a of pivot value. Okay, now where is my j? This is my j. So I'm going to swap 35 with 45. So when I do that, this is my new, sorry, this is my new array. So to start with 35, 36, 15, 45, 92, and 71. Now this is my new array, as you can see. And where is my jth position? This is my j. Now, once we complete the algorithm, we are going to return j. Okay, return j. Now, what is this j? J is nothing but it is giving me the position of the pivot value. So, as you can see, my pivot element has reached its correct position. So, this is the position. Now, all the elements which are less than that is on the left hand side, all the elements which are greater than this on the right hand side, and we can clearly see that it has reached its correct position. Okay, now what is going to happen next? So let us see. Now this is, let's write down our array 45, 92, and 71. This was our array. And this was the j value we had written. Now remember, j is equals to, we had given the we had stored this value. Now when it comes to the quicksort, when we call the quicksort function of a of 0 comma 5, we said that j is equal to the partition function. So here now j is going to get the value of 3. Next we had quicksort of a comma j plus 1, sorry, a comma 0 comma j minus 1, which is nothing but 2, and quicksort of a comma j plus 1, which is nothing but 4, comma high value is 5. Now, if you see carefully, what is this exactly indicating? Now, the first quicksort function is indicating this particular array, and the second quicksort function is indicating this particular array. As simple as that. Now we are further going to go ahead and work on this. Okay. So let us take the first quicksort, the quicksort of a comma 0 comma 2. Now once I call this quicksort, what is going to happen? I'm going to say that j is equal to partition of a comma 0 comma 2. Okay. So let us have a look at that particular array alone. So this is 35, 36, and 15. Now I know that I'm going to take pivot value as low value, which is nothing but 0. I is also going to get the value low value, and j is going to get the value high value. Okay. Now what I'm going to do, I'm going to check if I is less than j. This is the very beginning while loop what we followed. Now after that, I'm going to check if I is less than high. Of course, now 0, 1, 2. My high value is now changed. 2 is my high value. Of course, I is less than 2. Next condition we have to check is whether pivot value a of I, whether it is less than or equal to the pivot value. Yes, of course, this is also true. In that case, I'm going to increment the I value to 1. Once again, I'm going to check that whether I is less than high. Yes, 1 is less than 2. Now I'm going to check whether the A of I is less than or equal to the pivot value. Now in this case, this is becoming false, isn't it? So I'm going to stop it. Next, we'll go to the jth loop. I'm going to check whether A of j, which is nothing but 15, it should be greater than the pivot value. My pivot value is 35. This is also failing, as you can see. So since both the conditions are failed, I'm going to check. Remember, j value is equals to 2. Okay, so j value is still 2 and I value is 1. I'm going to check whether I is less than j, which is true in this case. So if still I value is less than j, simply we are going to swap the a of I with a of j. So once I swap a of I with a of j, we have the value 35, 15, and 36. This is the value I'm going to get. Now our j is over here and our I value is over here. Let us continue. Once again, I is less than j. Now I'm going to check while I is less than high. Yes, it is true. Next also I'm going to check whether 15 is less than or equal to 35. This is also true. Hence I'm going to increment the I value to 2. But then when I'm checking now whether I value is less than high, it is becoming false. Hence I'm not going to increment the value. Next, I'm going to check for j. Now I'm going to check whether 36 is greater than 35. Yes, this is true. Hence, I'm going to reduce the value of j. J is going to become 1. Now, once again, I'm going to check whether 15 is greater than 35. Now, this is false. Hence, I'm going to stop. Now, when I'm stopping here, what is going to happen is I'm going to check whether I is less than j, which is once again failing here. Hence, I cannot swap a of I and a of j. So instead, what I'm going to swap is I'm going to swap the pivot value and the j value. That is, I'm going to swap 35 and 50. So once I do that, my resultant array is going to be 15, 35, and 36, and this is where my j value is. Okay, and we are going to return the j value, that is this value. So this is 0, 1, 2. Now the what we are going to return here is j, the value what will be returned is 1, that is a position 1. So as you can see, now here the array is sorted. So what is going to happen? So this is our first one. Okay. Now let us see so this is done. We got the value 1. Now let us see this one. Now here, what we are going to do is j is equals to p of a comma 4 comma 5 is what we are going to call. So as you can see, let me write the array. It is going to be 92 and 71. And the positions are 4 and 5. Okay. Now, of course, pivot value is going to get the position 4. I also is going to get the position 4. And j is going to get the position 5. Now, initially, I'm going to check whether I is less than j. Yes, it is true. Once again, I'm going to check whether I is less than the high value. That is also true. Also, I'm going to check if 92 is less than or equal to 92, which is true once again. Okay, because pivot value, when I say 4, it is 92. It is going to be true. And I value is going to be getting incremented to 5. And now I'm checking whether 71 is less than or equal to 92. This is also true. Okay, but now when I'm checking whether I value is less than high, this particular condition will become false. Hence, I will stop this loop. I will now go to the jth loop. I'm going to check whether 71 is greater than 95, 92, and this becomes false. Now, I know that I value is 5 and j value is 5. Now, when I'm checking the condition whether I is less than j, this is going to become false. Hence, I cannot swap them. Okay, so instead now I'm going to directly go and swap the a of j and a of pivot. Okay, so when I do that, I'm going to get the value 71 and 92. This swap is going to happen. So this is nothing but the j value is here. So j value is 5. So this particular iteration is very small because we had only 2 elements, and this 5 will be returned as the position, as you can see here. I hope this is clear. Okay, so let us now see what we have done so far in a pictorially. Let us represent it quickly. So we started with 45, 36, 15, 92, 35, and 71. Okay, we called the very first quicksort function for this. We called quicksort of a comma 0 comma 8, which in turn called the partition function of a comma 0 comma 8. Okay, and it divided our array in this way. So it divided it as 35, 36, 15. Okay, here this was the pivot element. So pivot element we got here, and then it was divided as 92 and 71. So next we took this as a pivot element, this as a pivot element. We called the function quicksort of a comma 0 comma 2, and subsequently we called partition of a comma 0 comma 2. Here we called quicksort of a comma 4 comma 5. Subsequently, we call partition of a comma 4 comma 5. So once we did that, here what happened is we got the correct position of 35, of course, and then this is now further divided into, as you can see, a single element 35 and a single element 50. Now this is further, there are only 2 positions. So we got 71 as on the left hand side of the array, and we got the correct position of the 92. That was our pivot element. So these are the correct position we have received. Okay, sorry, this has to be written in this way. So after sorting, this was how it was. Okay. Now suppose I'm calling a quicksort function here for a single element. Let us see what happens. A of this position, the position of this was 0. Okay, so this is 0. comma 0, comma 0 is what it is going to be. And here it is going to be a of uh, 1, no, 1 is this one, 2, comma 2. So whenever you're calling this function, you can go ahead and iterate with the algorithm that we are not going to go further. The initial condition itself is going to fail, where we are going to check that I is less than j. So this itself will fail, which means we are going to get the j value as 0 itself. So whenever it is a single element, you need not go further. We can consider it as a sorted. Okay, so as you can see, this is the zeroth position of the array. This is the first position of the array. This is the second position. This is the third position, fourth and fifth, which means if at all I am writing it in the form of an array, it is going to look something like this, which is 15, 35, 36, 45, 71, and 92. So as you can see, our array is sorted. So this is how a quick sort works. I hope it is clear. So it might look like a very lengthy one. I've taken enough time to explain it slowly. So you can watch it again and you can understand it clearly. And you can take some other example also for your understanding. So let us see the complexity analysis. So the best case occurs when the pivot splits array evenly, and best case is always order of n log n. And average case is also order of n log n achieved with the good pivot selection. And worst case happens when your array is already sorted and your array gets divided in an imbalanced way. That is, if, for example, if at all you have an array like this and you choose a pivot element, but it is already sorted as in all the elements are on this side. So that is when you will have a worst case of order of n square. And if we are talking about the space complexity, best and average case is order of log n and worst case is order of n, that is constant. If the recursion depth becomes linear, that is when it is order of n. Okay, so this is about your time and space complexity. So if you have talked about the real world application of where do we use this quicksort, so we will use it in the database systems, use it for efficient retrieval and indexing. Indexing you would have studied in the DBMS. So that is where we will use the quicksort. Operating system also uses it for sorting processes and memory management. Quicksort is used. Computational geometry applied in algorithms for tasks like convex hull finding. Okay, so computational in a geometry mathematical point of view. Okay, and commercial computing also widely used to data analysis and report generation, sorting large data sets. That is where we will be using the quicksort algorithm. Okay, so that's all in today's session. Hope you have learned the quicksort in a better way, students. If there is any kind of doubt, please let me know and do comment in the comment section. So thank you for watching. Keep learning.